In the last lecture, we ended with 47 answered questions and one tangled heap. Admin behaviors, worker behaviors, system rules, weekend exceptions, all sitting in one pile. You cannot run C.R.A.F.T framework on a heap. C.R.A.F.T framework runs on one user story at a time. So before C.R.A.F.T framework, there is a step. And I want to be precise about this because students get confused here. Okay? So this step is not part of the framework. There is no 6 letters. C.R.A.F.T is still C.R.A.F.T. What I'm about to show you is a pre-processing prompt that runs once when your input is messy or multi-layered. If your stakeholder sends you a clean, single feature request, skip this entirely, okay? Go straight to context injection. But if your stakeholder is a Vladimir and your input is 47 Slack answers stacked on top of a phone call, you need to untangle the heap before you can refine everything inside it. And one of the things hiding in that heap is a displacement algorithm completed enough to break production if it gets refined badly. That's the story we are going to run through C.R.A.F.T by the end of this lecture. But first, the untangling. So here is the prompt. One paragraph, and I added it underneath the product Bible and raw answered questions. The input above contains the multiple feature requests mixed together. Separate this into individual, distinct feature areas. 2. For each state the core user need in one sentence. 3. Flag any contradictions between the requests. 4. Recommend a priority order based on the apparent business urgency. 4 instructions, and that's it. Hit enter. The AI separates the heap into 6 independent story areas: worker management, quota configuration, shift preference input, the priority algorithm with displacement, schedule display, and weekend combination logic. 2 of these you've already seen. Even though I didn't tell you at the time, worker management was the story I used in Module 2 when I taught you steps 2 through 5 of the framework. Vladimir quota about adding and removing the guys. Quota configuration was the story I demoed live in Module 3. The 8-minute timer, the notification hallucination I had to correct. The decomposition that produced both of those stories happened off screen. Now, you're seeing the wider map they came from. 3 more are straightforward. Shift preference input is the worker-facing form for the Friday window. Schedule display is the read-only view of the final weekly schedule. Weekend combination logic is its own mechanic, ranked first and second choices instead of single pick. And it sits at the end of the build because it depends on most of the others. And then there is the priority algorithm, story 4, the one with the modesty rule, the displacement mechanism, the timer tiebreak, and the quota the system has to enforce in real time during the Friday window. That's the one with the most business logic, the most edge cases, and the most ways to break. That's the one we are refining live. Okay? But before we do, the math. The course promise it's 10 minutes per story. That promise still holds. But this lecture is teaching you something the cold open didn't show you. When the input is a heap, you spend about 2 minutes on decomposition before the 10-minute clock starts. So the real math for a project like this is 2 minutes to untangle the mess, then 10 minutes per story. For one sprint-ready story, that's 12 minutes, not 10. I'm going to be honest with you about that number every time, because a project that would have taken 3 refinement meetings and 2 weeks of back and forth just collapsed into 12 minutes per story. 6 stories, about an hour and 10 minutes total. The framework still does what it claims. The 2-minute decomposition steps is the price of admission for messy input. Now, the priority algorithm. And I'm picking this one on purpose. If it holds up here, it holds up everywhere. Step 1 is context injection. I paste the product Bible, same one we built in lecture 1 of the previous, in the lecture 1. Step 2, raw request capture. I paste Vladimir's exact answers about modesty and greed. 1 or 2 delays is modest. 3 or more is greed. Modest workers have priority. If priority worker submits late and the quota is full, the system kicks out a non-priority worker. If everyone is the quota has priority, first come, first served. So I paste that whole exchange in quotes and I add the instruction line. Step 3, ask for structure. I run the simple prompt, output comes back. Title, enforce priority algorithm with displacement system. Story statements uses a radnik. In Serbian, it's a worker. Reference the Friday input window. Reference the quota. 6 acceptance criteria. The one I want you to focus on is given a worker has a requested second shift for 1 or 2 days in the upcoming week. When they request a day where the second shift quota is already full with non-priority workers, then the system displays the first non-priority worker from that day's quota and grants the slot to the priority worker. Notice what just happened inside that criterion. Every business rule we discovered in previous lectures live in there. The modest versus greedy threshold, the displacement mechanism, the word first, which is the time-stamped tiebreaker, 3 rules from 47 questions conversation compressed into one testable behavior. This is what an acceptance criterion looks like when the upstream work was done right. No ambiguity. No abstract words like fair. A developer can build it, a tester can verify it, you can demo it. Dependencies. The AI lists 3. Story 2, quota configuration must exist, or there's no quota to enforce. Story 3, shift preference input must exist, or there is no submission to evaluate. Story 5, schedule display, depends on this story, not other way around. So this one ships before the display, after the input form, alongside or after quota configuration. Assumptions. 3 flagged for stakeholder confirmation. The displaced worker is not notified inside the application. They discover it next time they log in. Days off do not count toward the priority calculation. Tiebreaker among same priority workers is timestamp. First submission wins. All 3 are real questions the team needs to confirm before estimating. Risks. 2. Raised condition during simulation submission in the Friday window, and the question of what happens when a displaced worker resubmits the same day. Both go on the refinement agenda. That's steps 1 through 3. About 4 minutes of actual prompting. The story has a structure, it has a business rule baked into testable criteria, it has flagged assumptions and identified risks. Step 4 is force edge cases, is our next entire lecture. There are enough hidden edge cases in this story that I'm giving them their own time block. Step 5, test and validate runs at the end of the case study. Notice what changes and what stays fixed across the 6 stories. The product Bible remains constant. Only the raw request changes. The full set of stories with a 5-step completed lives in my schedule case study pack, which is the PDF download for this module. Read that PDF the same way you read a worked solution in the math textbooks. Not for the answers, but for the technique. Okay? And notice how each raw request narrows it on the different subset of Vladimir's answers, and how the structure prompts produces a different shape of story depending on what kind of work it describes. The pattern is the lesson. Okay? In our next lecture, we zoom in on the step 4 for the priority algorithm story, the edge cases, the displacements timing, the Friday holiday, the partial submission, the cases that would have broken the application if the AI hadn't asked the right questions before development started. I'll see you there.